Hello students, this is 10th class mathematics. Today our chapter 1 is real numbers. We have completed successfully till here. Now we have seen a brief introduction on form of positive integers. Now we will conclude with this and we'll go to the problems. Now we have as already discussed, every number is of the form 2m or 2m plus 1, and if in terms of 3 it is in the form 3m plus 1 or 3m plus 2, or in terms of 4 it is 4m plus 1, 4m plus 1, 4m plus 3, and 5m plus 1, 5m plus 2, 5m plus 10, 5m plus 4. So here is a task for you students. Try to write the form of positive integers in terms of 10, which means 10m plus 1 so on till it goes until 10m plus 9. In the same way, you try to write in terms of 11 and 12 and check with the answers. 11m starts from 11m to 11m plus 10. 12m starts from 12m to 12m plus 11. Check your answer with these two. If you are right, well and good. If you are wrong, do it once again. You will get it correct for sure. And now we are moving to the next set of problems. I think you have noted down, students. If not, just go back and pause the video and note it down. And now this is, here we are going to see some problems from your exercise 1.1. Okay students, I will dictate the question, you just note it down. Using Euclid division lemma, show that any odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. I am repeating the question, students. Using Euclid division lemma, show that any positive odd integers are of the form 6q plus 1, 6q plus 3 and 6q plus 5. Yes, you can see here this is 6q. We have already discussed any number is in the form in terms of 6 will be, yes students, tell with me, 6q plus 1, 6q plus 2, 6q plus 3, or I'll write 6q plus 3 here, 6q plus 3, 6q plus 4 and 6q plus 5. As students, we need to prove this. Any odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Yes, yeah. From Euclid division lemma, we know A equal to BQ plus R. What is R? Reminder, and A is our number, this any number, B is 6. Here you can observe 6 is even, which means 6 into anything will be even. Simple thing, students. You just need to note down E for even into even will be 2 into 2. Example 4 is even into odd will be even. Same thing, odd into even. These both are similar, students. Just we have reversed them, is even, and odd into odd is odd. Yes, okay, understood, students? And we need to note another thing. I am writing here, even plus even, even plus odd, odd plus even, odd plus odd. Yes, even plus even. Take 2 and 4. 2 plus 4 is 6. 6 is a even number. Even plus odd. 2 plus 3 is equal to 5. 5 is an odd number. On odd plus even. 3 plus 4 is 7. Again an odd number. And odd plus odd. 3 plus 5 is 8. It is even. Note down these two tables, students. We are going to see a lot of things on that. and from here this is 6, which means even. In here we are doing multiplication, so even into is here, here and here. We can observe, if you multiply even with any number, if you multiply even with even or even with odd, you get even only. So 6 cube is even. All the 6 cube are even, students. Remember, even into any number, either it is even or odd, is always even. Now we come to the addition. These all are even, right? This number is even, but we need to know 6 cube plus 1 is even or odd, and we know from here even plus odd is odd, and even plus even is even. So if this is already even, and if you add an odd number, this will be odd. Yes or no? Yes, even plus odd is odd. And 6q is already even, we know before, and 2 is even. So 6q plus 2 will be even, and 6q is even, 3 is odd, so this will be odd. This is even plus even, even plus odd is odd. So the question is, we need to get odd integers. From here, which are all odd? 6q plus 1 and 6q plus 3, 6q plus 5. So we have proved that any number is of the form 6q plus 1, 6q plus 3 or 6q plus 5 is odd. Okay students, this is the end of the question. Just note it down. Pause the video and note it down. I am going to erase it. We will go to the next question. We might need these, students. I am not erasing this. Now, next question. Using Euclid division lemma to show square of any positive integers. What is that, students? Using Euclid lemma theorem, we need to show square of any positive integers is of the form what? 3p and 3p plus 1. So we need to show any positive rational number, when we square it, it will be in the form of 3p or 3p plus 1. To do this, we need to know the form of numbers in terms of 3. We have learned it before. Any number in terms of 3 is in the form of, yes students, 3m, yes, 3m plus 1 and 3m plus 2. This is the first step. You need to write any number is in the form of 3m, 3m plus 1 or 3m plus 2. So he asked square of any positive integer. So we need to find the square of these three numbers. You need to write step by step in your exam, students. Don't do like this. You just need to write step by step. You can get how to write the step by step in your examples. And now if you square this number, you get 9m square, and here a plus b whole square is a square plus b square plus 2ab, which means 9m square plus 6m plus 1, and this is 9m square plus 12m plus 4. Is that clear, students, till here? He asked square of any positive integers. Any positive integer in the form these three numbers, so we square them. Now you can observe these can be written as 3 into some k. Yes or no? 3 if you take, okay, we will do another step. 3m square, 3 into this is another number k. Yes or no? Yes. any number, we can take it as another number. This is one new number. Sum, we are multiplying 3 to a square of a number, it will become a new number k. Now here we can see we can common 3 from these two numbers, which is 3m square plus, we can take, what can we take, students? We can take even m as common, because we have m also common, plus 1. And here if we take 3m common, we have another 3m from these two, students, plus 4. And you can also take, if we take 3, okay, let it be 4 plus 4. Yes or no? Yes. Now I am arranging this part, students. We need no more space. I think you have noted this assignment. Okay, write it clearly. We can have common 3m and 3m plus 4, and outside we have 4, right? Now this is 3m, right? So no need of 3m, student. Okay, let it go, students. We can write 3m, and this is as some new constant k plus 1. Yes or no? Yes. And here 3m, and this is also another new constant. Take it as k. These k's are not equal, students. These k's are just relative. This doesn't mean this k, this k, and this k are equal. If you are a bit confusing, I am changing the variables as L and P, L and Q plus 4. Yes or no? This is 3k itself. This is, see, m into L can be another new number, right? Another new number or another new variable, x plus 1. Here these two, m into q, can be another new variable, y, plus 4 can be written as 3 plus 1, student. Yes or no? Yes. We are done with these two. If we solve this, common 3, and here it is y plus 1 plus 1. This y plus 1 can be another new variable, 3z plus 1. Yes, students. So can you observe, any number, any square of a number, these are squares of the numbers, is of the form 3k or 3k plus 1. Both are same, students. When we are discussing up to the forms, we need to say relatively. That means we need to say answer independent of variable. That means any square of the number is of the form 3p or 3p plus 1. Hence proved. Okay, students, I think you understood. Note down the solution. Pause the video. I'm going to the next problem. Okay, students, note down next problem. Show one and only one out of n and n plus 2 and n plus 4 is divisible by 3, where n is a positive number. We can write positive like this, students, but not in the exam. Okay, here he said n is a positive number. We already know, and the question is we need to prove one of these number is divisible by 3. So to make it easier, we can take n as any form, 2m plus 1, 2m plus 2m plus 1, or 4m plus 1, and 4m plus 2, or 4m plus 3. But for making our problem easier, we'll take this n as 3m or 3m plus 1 or 3m plus 2. We need to do whole problem with all these three numbers, because here we know 3m is divisible by 3, and when you add all these we will get to know whether which is divisible by 3 or not easily. So we took n as 3m or 3m plus 1 or 3m plus 2. For first case, let n equal to 3m. If n equal to 3m, what will these become, students? 3m plus 2 comma 3m plus 4. Here, students, from Euclid's division lemma theorem, I have already told this is remainder, and remainder can't be greater than what? Divisor. So this can be written as, here 4 can be written as 3 plus 1, right? So when we take 3 common, this can become 3m plus 1. Yes or no? So the final set are 3m, 3m plus 2 and 3m plus 1. Which number is divisible by 3, students? Here 3, because here they already mentioned, so one and only out of n comma n plus 2 and n plus 4 is divisible by 3. Here only this is divisible by 3, students, and all these 2 will leave a remainder of 2 or 1 when divided by 3. This is what we have discussed and learned in our Euclid division lemma theorem. So in here, n is divisible by 3. N is divisible by 3 when n is in the form of 3m. And second case, when n is equal to form of 3m plus 1, what are these numbers, students? 3m plus 1 comma 3m plus 1 plus 2, 3m plus 3, next 3m plus 7. Yes, here you can observe, students, the remainder can't be greater than the divisor. So here we can take 3 common and write it as a new variable k. And here also we can take another 3 common and we can take a new variable and write it as what is this, students? 3m plus 1. Yes or no? This is 7 is 6 plus 1. Here we can take 2 common, and here we can get, sorry students, we have made a mistake. 3m plus 1 plus 4 is 5. 3m plus 5. 5 can be written as 3 plus 2. If we take 3 common, we will get 3l plus 2. So here we can see, when we take number in the form of 3m plus 1, first number, that is n, will leave a remainder of 1, and second number is exactly divisible by 3, and third number will leave a remainder of 2. Here n plus 2 is divisible by 3 when n is in the form of 3m plus 1. Here when n is in the form of 3m. Okay, students, final we need to do a final case, which is n is in the form of 3m plus 2. What are the numbers, students? 3m plus 2, 3m plus 4, and what is this? 3m plus 6. Here you can see remainder less than divisor. Here it is not less than divisor. Same, students, here. So what? 3m plus 4, 3m plus 4. So we can write it as, next step as 3m plus 2 comma 3m plus 1 comma, and here see 3m plus 6. If we common 3, it will become 3 into m plus 2. That means another new constant, say k. Here you can observe, students, here the divisible number is n plus 4, where n is in the form of 3m plus 2. Yes or no? Yes students, so this is our answer students. As already discussed, if n is in the form of 3m, n is divisible by 3. If n is in the form of 3m plus 1, n plus 2 is divisible by 3. If n is in the form of 3m plus 2, n plus 4 is divisible by 3. Here we can say only one of these three numbers. Yes or no? Here only n. Here only n plus 2. Here only n plus 4. In all these three, only one, exactly one, either n or n plus 2 or n plus 4 is divisible by 3, and these changes with conditions. Okay students, note on the question, pause the video. Now I am going to give some task for you. Okay students, we are going to end the session. Fastly note on the problem. Yes. Okay, question students, use Euclid's division lemma theorem to show cube of any positive integer is of the form 9m plus 1 or 9m plus 8. Question is, show that any positive integer is in the form, any cube of any positive integer is in the form of 9m plus 8. I am giving you the hint students. Hint is, any number is in the form of 3m or 3m plus 1 or 3m plus 2, right? 3m plus 2. From here cube these, and I've already discussed, if the remainder is greater than 3, you break that into 3 plus something and you common 3 and make another new constant. If there is 3k square plus 6k, you take 3k common, and what will be remaining? K plus 2. This k plus 2 will be another new constant L, and the old constant k into L will be another new constant C. This process we have done in the previous squaring sum students. You can check there. Okay. If you cube this, all the cube of this number will be in the form of 9m plus 1, 9m plus 8. Answer is also here. You just need to do the process. Thank you students. We are completing the session. Thank you.